Lesson 5.3 explores compound interest, and in this video we're going to focus on the formula for compound interest. And I'll start by showing you how it's developed, and then we'll take a look at the formula and run through a quick example. Before we talk about compound interest, let's take a look at simple interest. You probably remember that if you want to compute the amount of interest you're going to earn on a particular principal at a given rate over a period of time, we use I equals PRT. Now, this formula only tells us that interest amount. That's money. If you want to know how much you'll have total, your accumulated amount, we set A equal to the original principal plus that new interest. Now we can substitute PRT for interest and then factor and come up with what we call our simple interest formula. Remember, this is only computed off the original principal, the interest earned over a period of years. So this is simple interest. Now what usually happens is when you invest a principal amount, it will earn some interest, and then that interest will be added back in, giving us an accumulated amount, and the next time the interest calculation is made, it is made on that accumulated amount. In other words, your interest also earns interest, and this is called compound interest. So what I want to take a look at now is how we can develop a formula to compute compound interest. So let's sort of draw a line here and put a period on our simple interest, and then we'll remember this is simple interest. I just want to make sure we indicate that so there's no confusion. Okay, so let's start to develop a formula for compound interest. So what happens is the interest rate, the nominal interest rate that you'll make for a year, is divided up by the number of times that you're going to calculate that or compute that interest during the year. So we'll usually write that as R over M. So for example, if you're going to earn 8% interest and you're going to compound that, say, 4 times a year, quarterly, then each time you're going to use only 0.02 or 2% of that total 8%. So for example, what happens the first time we invest our principal, and we're going to compute the interest at 1 plus 0.02. And that'll be our first accumulated amount. Then the second time, we'll take the A1, which is our accumulated amount, and we'll compute the interest again. And then the third time, we'll take the second amount and compute the interest again. And then finally, we'll take that third amount and we'll compute the interest one last time. So we've done that 4 times during the year. Now, because we've used information from the prior equation each time, we could really write A4 just in terms of the principal. We'd have A1, which looked like this, times another one of those. That makes A2. Times another one of those. That makes A3. Times another one of those. That makes A4. I forgot a 1 plus in there. Shucks. Anyway, my point is that you'll see that we multiplied by 1 plus 0.02, in other words 1.02, 4 times. And we can use exponents to represent that. So that I wanted black ink there. So that A4 could actually be written as our principal times 1 plus 0.02 to the 4th. Now remember, we were going to compound this quarterly, so basically we made it through 1 year. If we were going to go to 2 years, we'd end up at A8, and this number would then be an 8, and so on. Now, let's think about where these pieces came from. This 0.02 is really just our R divided by M. M was the number of times a year that we were computing or compounding the interest, and R was our interest rate. This number here came from multiplying our M times our number of years, which was 1. So that's M times T. And if we're going to write this formula for the accumulated amount in terms of just our variables, we'd end up with P times 1 plus R over M to the MT. And this happens to be our compound interest formula. So let's go ahead and make this our official formula for compound interest. We'll put a red box around it the way we did on the last screen. And you can see here that I've indicated what these variables in the formula represent. So A is the accumulated amount, P is the principal, R is the interest rate, and then M, remember, is the number of times per year that we're going to make this calculation. We call it the conversions per year. So if you're going to do it annually, M would be 1, semi-annually, M would be 2, quarterly, M would be 4, monthly, M would be 12, and daily, M would be 365. Those are the usual numbers that we'll use. Finally, T is just the term, the number of years in which you're doing your calculation. So this is our compound interest formula, and let's just do a quick example on the next slide, and then we'll wrap this video up. So it's one thing to know where the formula came from, and it's another thing to use it to do some calculations, and that's what we want to do now. So let's just find the accumulated amount on a $12,000 investment with a nominal interest rate of 5% over a course of 10 years, and we're going to compound that thing quarterly. So here's what that would look like. We write down A equals, and then we're going to take 12,000, our principal, we'll multiply by 1 plus 0.05 over 4, and then we're going to raise that to the 40th power. Our exponent is 40 because it's 4 times 10. That's where that exponent came from. And I went ahead and typed this in on my calculator, and I came up with an accumulated amount of $19,723.43. So that's pretty good for a 10-year investment there. Okay, so that was just a brief introduction to compound interest with one quick example. And the other videos will show things like present value and effective interest rate. So please go ahead and look at those also. Good luck.